All right, we're back for the last part here. We're going to come up to number 7 and do that. So let's say we want to do a reflection. Reflect point L, 5 comma negative 2, across the line x equals 1, across the line y equals negative 4. So now it's not an axis, it's a different line. If we do x equals 1, x equals a number is a vertical line. So if I go to the x-axis, here's 1, and I'm going to draw a vertical line here. So this is the line x equals 1. So we're going to take point L, which is to the right of this line. We're going to reflect it. So that means we're going to go to the left. Now here's where you have to be careful. When I count to the line of reflection, which would be here. I'm going to go left. 1, 2, 3, 4. From this line, not the y-axis, from this line I go 4 more. 1, 2, 3, 4. And so it actually puts us here at negative 3, negative 2. So here is L prime at negative 3, negative 2. Okay, so another word that you're going to hear with reflections is symmetric. How I could fold this and L would fold right onto L prime. The pre-image will fold onto the image. Okay? Across the line y equals negative 4. Now y equals a number is a horizontal line. So I go to the y-axis, negative 4 is here. I'm going to draw a horizontal line. So there's y equals negative 4. Remember that when you do your counting, we have to think perpendicular, right angles. So if we're above this horizontal line, we're going to count straight down and go below the line. So from L, we would go down 1, 2 to get to the line, and then we would do 2 more on the other side. There's L double prime, which is 5 comma negative 6. 5 comma negative 6. Those are the coordinates, x comma y. Okay? So what you need to do is you need to draw the lines. That's really important so that you can then count. So we're going to go down to number 10, and we're going to draw the reflection for a triangle ABC across the line y equals 1, which is horizontal, and then x equals 2, which is vertical. So we'll do one at a time. Let's do y equals 1. So on the y-axis, here's 1. Let me draw that line, horizontal. Okay. This is why I like to use different colors as well. It just makes it stand out. Now, we have to reflect each point. You have 3 points here, 3 vertices. So A, we're going to count down to the line. 1, 2, 3, 4, 5. On the other side, the same thing. 1, 2, 3, 4, 5. Here's A prime. And then B, down 2. From there, down 2. There's B prime. And then C, down 2. From there, down 2 more. However I count to get to the line, I do the same thing on the other side. Now I can connect. And those triangles, again, should be congruent. It's just that they've been reflected. Okay, let's reflect across the line x equals 2. That's a vertical line. X-axis, here's 2. So I'm going to draw that vertical line. Now something interesting happens here. Notice that point A is already on the line of reflection. Now the idea is that I count to the line and then I count the same amount on the other side. Well, if we're already on the line, I don't have anywhere to count. So this is A double prime. I'll use double prime. So that's the same thing as A double prime. If you're on the line of reflection, don't move. B is on the line of reflection. So that's also B double prime. Now C is to the right of the line, so I'm going to count 2 spaces to get to the line, and then 2 spaces on the other side. There's C, double prime. Now I connect the dots, and there's the reflection right there. Okay? So a lot of this is very visual. Now we're going to do one more kind of reflection. We're going to go back up to number 8, reflect point L, 3, 2, across the line y equals x. The line y equals x is the set of ordered pairs where x and y are equal. 0, 0, 1, 1, 3, 3, -2, -2, where x and y are the same. Now, if you graph that, I'm going to graph the point 0, 0, 1, 1, 3, 3, -2, -2. What we end up with is a diagonal line that goes through the origin. Here's the line y equals x. Now this is kind of cool because there's an intuitive way to do this, and there's also a rule for it. There's a shortcut. This one, I can't just really count. We can't count diagonally. That's difficult to do. And you know you have to do perpendicular. You're going to have to make a 90-degree angle. Now from here, you might be able to tell that, okay, I'd have to be the same number of spaces or the same distance on the other side of the line. And what I can do, it's going to be here. There's L prime. And so L is 3, 2. L prime, that's 2, 3. Okay, interesting. Let's do a different, I'm going to put a different point on here. How about 5, 1? 5, 1. I'm going to call that A. Now again, if you're thinking perpendicular, you'd be something like this, somewhere over here. You're going to end up at this place, which is 1, 5. So if A is 5, 1, A prime is 1, 5. Notice anything going on with the pre-image and the image values? Let's do one more here. Let's say we picked, let's do -4, 2. I'll call that point B. Now again, you're thinking 90-degree direction. So I'd go somewhere down like this and to the right. You're going to end up here at B prime, which is 2, -4. So B is -4, 2, but the image is 2, -4. Notice what happens to x, y. Basically, your x's switch and your y's switch. That's all you're doing, is you're changing your x and y values. So there's a rule for this. X, y becomes y, x. So that's an easy way to do this. So if I told you that it was 5, -3, and you want to reflect across the line y equals x, all you have to do is switch x and y, -3, 5. So switch x and y. That's all you have to do. That's the rule. Boom, right there. Now, visually, there is a way to count this. I'm going to go back. I'll take point A. If I count horizontally to the line, if I go left, 1, 2, 3, 4, that gets me to the line. Now, I can't go left again, because if I put the point here, that's not perpendicular. That doesn't make a perpendicular to the line y equals x. However, if I go left 4 and then I go up 4, look at where it puts me, at A prime. If I'm at L, left 1, up 1, there's my reflection point. If I'm at B, I would go right 1, 2, 3, 4, 5, 6, and down 1, 2, 3, 4, 5, 6. So I can count, I could still count if I want, as long as I'm counting the same number. And you might be thinking, why would this work? Well, now you don't need to write this down, but think about it in terms of slope. This is y equals 1x, and the slope is positive 1. Perpendicular slopes are opposite reciprocals. Now as a fraction, that's 1 over 1. the perpendicular slope would be negative 1 over 1. Okay, so perpendicular lines, if I go left 4, up 4, then it would be 4 over negative 4. Okay, normally we go up when we're doing slope. Okay, instead of going left 6 and up 6, we went right and down 6 and negative 6. So the slope is negative 6 over 6, which is negative 1. So if your slope is negative 1, that's going to create the perpendicular right there for that. Okay, now, again, counting might be a little more confusing. So if you can just remember the rule, all you do is switch x and y. So we're going to do one more here. Draw the reflection for triangle ABC across the line y equals x. So the first thing I'm going to do is plot that line. I'm going to connect that. We'll graph the line. All right, so there's y equals x. Notice that the triangle is on both sides of the line. Whoops. Notice the triangle is on both sides of the line here. So what we do is we go point by point. A is negative 3 comma negative 2. So that would become switch x and y, negative 2 and negative 3. Okay, I'll do this in blue. Negative 2 and negative 3. That's A prime. Okay, see how that would connect and make the 90 degrees? Now point B is negative 3, negative 5. Switch x and y, that's negative 5 and negative 3. Or, if I don't want to do this, I could count from B, left 2, up 2. Negative 5, negative 3. There's B prime. And then C is negative 1, negative 5. I can switch x and y, negative 5, negative 1. Or I could just go left, 1, 2, 3, 4, and then up, 1, 2, 3, 4. There's my C prime. And if I draw this now, if I connect this, there's my triangle. Now, that's harder to see the reflection, but if I turn this so it kind of looks like this is a vertical line, now do you see how these match, how they correspond to each other, how the points correspond? And that is the end of the notes.